so that people know it's not the same stuff, because almost all the other students of mine are coming from different school. So, all right, give the following functions. Okay. Given the functions, answer the questions. All right, so we're trying to, so what we're doing here is graphing quadratics, right? So it looks like you already filled this out, or were you just, are you just trying this on your own?
I was trying it and then I got stuck. Yeah.
Okay, so you're so far so good. The number of zeros always is the degree. The number of possible zeros is always the highest degree of a variable if it's a polynomial function like this. Okay. And the maximum number of turns is one less than that. So that is correct as well. Okay. So to find the zeros, the first thing you're going to want to do is factor it if you can, which you're doing here. You took a negative x out, or a negative x cubed out, and that left you with the x squared plus 3x plus 2. And then you want to try to factor this more if you can, which we can. Do you remember how, look over to the right, x squared plus 3x plus 2. Do you remember how that's called the trinomial? You remember how if you have a trinomial, quadratic trinomial, it's like you can unfoil it sometimes?
I think I kind of remember that.
Okay, so this is one of the styles of factoring. You can go and on my website go check out other factoring videos.
Okay.
But yeah, what you would do here is factor an x. So this is your first. Your first comes from here, and your last comes from here. So the last, how can you break up 2? It's really just one way, 2 and 1, right?
Yes.
So that's how you can break it up. And now let's check if that works by checking our outside plus our inside, our outside plus our inside. So 1 times x is 1x, 2 times x is 2x, and what's 2x plus 1x?
3x.
3x. So that is how you factor it. Okay. If I had given you this problem, how would you well, if I said expand this, what would you do to expand that?
Use the FOIL method.
That's right. You would go first, right?
Mm-hmm.
You would go first, which is x squared, outside, which is 1x, inside, which is 2x, last, which is 2, and you would add the like terms, which would give you 3x. So that's all we're doing when we're factoring this. When we're giving it to when it's given to us in this form, we're turning it back into the thing that we have to foil. I call that unfoiling.
Okay.
Make sense?
Yes.
So what does that mean about my zeros? What are my zeros?
So
it's x plus 2 and x plus 1. So we have an x cubed, we have a negative, which doesn't really mean any matter. It affects the end behavior, but it doesn't affect anything else. It doesn't affect zeros. We have an x cubed, and we have an x plus 2, and we have an x plus 1. Do you remember how to do this, or do you want me to just show you for this one?
Like you take x plus 2 and x plus 1 and set it equal to 0.
That's right. X plus 2 equals 0. X plus 1 equals 0. And also you said this one equal to 0. X equals 0 3 times, really. There's 3 of those. That's called multiplicity 3. Got it? That 3 right there means that there's 3 of them, but that doesn't give you more zeros. That just changes kind of what the graph does at that value. Okay.
Okay.
So here, these ones, each one's of these, we're going to get x equals -2. So there's one of my answers. We're going to get
Mhm.
x equals -1. There's another answer, and we have x equals 0. Now, that's only 3 zeros, right? But there was a possible of 5, but that's because 2 of the ones we didn't count are multiples of these, because it was like I had x times x times x times x plus 2 times x plus 1, but I didn't have to list the 0 out 3 times. Make sense?
Okay. Yeah. Yes. Okay. That's what I struggled on because I was like, I don't know where the 3 other zeros come from.
Now let's take a look at what that actually looks like on a graph. So if you had negative x cubed times x plus 2 times x plus 1, x plus 2, x plus 1, and if I look at that graph, look at what happens. I'm going to zoom in. Look at what happens at 0. Do you see what happened at at 0?
Mm-hmm.
It goes through it, but it inflects at it. It looks like a cubic graph.
Okay.
And
Yeah.
at -1, it just goes straight through it. And same with
Yeah.
-2, it just goes straight through it. Okay, so if I zoom out again, that's what's happening with that graph.
Okay.
So the multiplicity of the 0 tells you what happens. If it was multiplicity 2, then it would actually bounce off of the graph. It wouldn't go through it. It would bounce off of it. Instead of doing this, like you see right there, it would bounce and go back the other direction. It wouldn't go through it. It would hit the graph and then bounce off. Watch, I'll show you. If I change it to squared, I change that to squared, my graph is going to look different. See how it bounced through?
Yeah.
It bounced at 0. That's multiplicity 2. This is multiplicity 1. It goes straight through. It doesn't inflect or do anything weird. Just goes straight through. That's multiplicity 2 or 4, to be honest with you, or 6 or 8, any even multiplicity. And what I mean by multiplicity is the number up here. When you factor it, see how there's a 1. You don't have to write a 1, but you could write a 1 here. So that has this 0 has multiplicity 1. I'm going to write M1. And this 0 has multiplicity 1. And this 0 has multiplicity 3. Has your yeah, see, look, it even uses that word. So they do want find the real zeros, including any multiplicity. So they wanted you to tell the multiplicity. Okay. Now the end behavior has to do with the degrees, the degree of the function and the sign of the leading coefficient. So the end behavior, I'm going to make a little chart for you here. The end behavior has to do with the degree of the function and the leading coefficient. Do you understand what I mean by leading coefficient?
Yes.
Okay, so here's what the end behavior is. If the leading coefficient is positive, you either have positive or negative leading coefficients. And the degrees, you either have even degrees or odd degrees. Okay.
Okay.
So we're gonna make a little chart here. Let me erase this to give us some space for my chart. So if the leading coefficient is positive, that means that the right behavior is going up. At the right, it's going up, whether it's even or odd. And if the leading coefficient is negative, that means that the right end behavior is going down. Make sense? And then if it's an even degreed function, then the left behavior is doing the same thing as what the right behavior is doing. So they're either both going up or both going down. If it's an odd degree function, the left behavior is doing the opposite of what the right behavior is doing. Okay?
Okay.
So that's how that works.
Okay. Okay.
That makes sense to you?
Yeah. So if it's like x to positive infinity, then
Yeah, that's
way?
right. So that means the right end behavior. Yep. X to positive infinity means that's the right end. That's the right one here. I'll use a yellow. This is this side. Okay. And x to negative infinity is this side.
Okay. Okay. Yeah. Okay. Now that makes sense.
So what is which one of these four boxes, 1, 2, 3, or 4, does our equation fall into?
Is it
What's the leading coefficient?
1?
Not
-1.
-1. So is it positive or negative?
Negative.
Good. So it's a negative. And is it an even or odd function?
An odd function.
That's odd because it's the biggest degree. That's right. So it's odd and negative. So it's this one right here.
Okay.
It's left. So it's the end behavior on the right is negative infinity. And the end behavior on the left is positive infinity. Okay. Do you understand that? And you can see it on your graph. Look at my graph. Whoops, I changed it, remember? Let me change it back. This has to be cubed. See what's happening on the left? It's going up. See what's happening on the right? It's going down. Yeah. Okay?
Okay. Okay.
All right, the next one says sketch a graph of the function. Okay, so, and then it says sketch a graph. So to sketch it, it's going to go through at -2, at -1, and at 0. So there's going to be dots at all three of those places. The left end behavior was up, so you draw an arrow up. The right end behavior is down, so you draw an arrow down. And it goes, since it's odd, since the multiplicity is 1 for these first two zeros, it's just going to go straight through. So you just draw it straight through, turn it around, draw it straight through. And now this one, since it's 3, it's going to go through, but it's going to do a little bit of a zigzag through. So here it's going to go like that. And then you can kind of clean it up, make it look better. Let's try that again. So at this, it's going to go like this. Whoops. It's going to go. You see how I did a little slant there?
Yeah.
That's what's going to happen. And you don't have to worry about drawing them perfectly, because you don't necessarily know how high it's going to go or how low it's going to go, but it's going to something like that. Okay?
Okay.
All right, so you try number 14. Tell me what to do. Tell me what you're going to do.
So the number of possible zeros is 3.
Mm-hmm.
And then the maximum number of turning points is 2.
Good.
And then, so I took out x.
Good.
And then it was x squared plus 4x plus 4. And then, then it would be x plus 2, and then x plus 2 is equal to 0.
Yep. So what's the multiplicity, or what are your zeros and what's the multiplicity?
My zeros are 0, -2, and -2.
Mm-hmm. So
And-
what that means is 0 and 2 and -2, but there's multiplicity 1 for 0 and multiplicity 2 for -2. Right?
Yeah.
You don't really have to list it twice if you don't want to. You can just write multiplicity 2 next to it if you want.
Okay.
Okay. Well, I don't know how your teacher wants you to do it. So what's gonna happen on the end behavior? What's the degree?
The degree is 3, so it's odd.
Good. So it's one of these two.
Yes. And then the leading coefficient is +1.
Very good. So it's this one here, right?
Yes.
So it's down to the left and up to the right, which you've done correctly. So now it's just a matter of graphing it.
Okay.
So,
Okay.
and it looks like you've already done that, but I'll just show you how to do it because I don't know if you did it or if you were watching from a teacher doing it or something. But here's 0, here's -2, and you know it's going to be down on the left. So I just start with that, and it's going to be up on the right. So I like to just draw in the arrows on the end. And then what's going to happen when it approaches that -2? Is it going to go through or bounce?
Will it go through?
No, it's going to bounce because remember what I said, if the multiplicity is even,
Mhm.
it bounces.
Oh, okay. Right.
So it's going to bounce off and come back down. Got it? And then it's going to go back up at some point, and is it going to bounce or go through?
Go through.
At 0. Yep, it's going to go through because that's multiplicity 1.
Yeah.
Odd multiplicity goes through, even multiplicity bounces.
Okay.
Okay?
Okay, cool.
That's roughly what it should look like. Make sense?
Yeah.
Let's do some more. All right, so this one, the multiplicity or the possible zeros are 5, possible terms are 4. Now we're going to factor this, and to factor this one, see, you should always take out least common denominator. And see, do you see how all of them have a factor of x squared in them?
Mm-hmm.
So let's just take that out to start. It'll just make your life easier. So if I took an x squared, what would be left here?
4x to the third.
Good. And what would be left here?
-20x to the second. Yeah.
Second.
X squared.
What would be left on the next one?
9x
And the last one?
plus 45.
45. Good. Now, this is another one of your factoring things. And this, because see how there's 4, it's not a trinomial, it's a quadnomial or a 4-term polynomial.
Mm-hmm.
So if it can factor, sometimes the way it's going to factor is by grouping. So what we're going to do is we're going to group these two together and see what we can factor out of those. And we're going to group these two together and see what we can factor out of those and hope that we have the same factor left over.
Okay.
Okay. So if I group those two, I'm going to take a 4x squared out of here. And that's going to leave me with an x minus a 5. And don't forget, we still have that x squared on the outside. So I can't forget that.
Mm-hmm.
Okay. And then I'm going to take a -9 out of here. When I take a -9 out of there, what's going to be left over?
X plus 5 or x minus 5?
And x minus 5 again. And do you see how now this and this both have the same factor? You see how they both have this factor because they're being multiplied? It's the x minus 5.
Mm-hmm.
So I'm going to take that out. I'm going to take that out of both of these, pull that out front. Okay.
Okay.
So I'll have an x squared, which was already there. I'll have an x minus 5. And then the thing that's left over is a 4x squared minus 9. Okay. But now this, we can factor this too, because this looks just like You remember how when you had a squared minus b squared, that factors into a plus b and a minus b?
Mm-hmm.
You remember that?
Yeah.
That's another factoring. That's called special factoring. And that's exactly what I have here, because this is 2x squared and this is 3 squared. So this is going to factor further into 2x plus 3 and 2x minus 3. Do you follow that?
Oh, yeah. Mm-hmm. Yeah.
You get that? Okay. So I'm going to clean this up a little bit and make it look a little bit nicer so that when you go back through, you can see what you've done. I'll keep the color coding in here. There's x squared. There was x squared. There was x squared. So notice, how many zeros do I have? You know that the total possible is 5 and the total possible turns is 4. But look at all of these things and tell me how many zeros I have.
4.
That's right. One of them is 0, right?
Mm-hmm.
So x equals 0, and that has multiplicity 2. I've got x equals 5, right?
Mm-hmm.
And that has multiplicity 1. And then I have, can you do this in your head for me? If you set that equal to 0, what would you get?
3 halves.
Negative 3 halves for that one.
Oh, negative 3 halves. Yeah. Okay.
And you'd get positive 3 halves for this one. Got it?
Okay. Yeah.
So total, I have 4 zeros, but one of them is multiplicity 2. And what's the end behavior? Let's go back and remind ourselves of what we're looking for. Think about that chart. What's the degree?
It's odd.
And what's the leading coefficient?
Even.
Positive or negative?
Or positive, sorry. Positive 4.
So let's even write that down. Positive, odd. Positive and odd. Positive and odd is down and up. I'm going to show you a little trick that helps me remember these things. Okay. What's the simplest positive odd polynomial function you can think of? If it's a positive leading coefficient, it's going to be plus, right? Just plus 1. And if it's odd, how about just x to the first power?
Oh, right.
Right. And what does that do? What is that? What does y equals x look like?
Linear.
It's just a line, right? It goes down to the left and up to the right. That's how I remember it. What if it was y equals negative x? That just changes what? It's still a line, right?
Yeah.
It just goes down. It goes up to the left and down to the right. Does that make sense?
Oh, okay. Okay, yeah.
And what about, let's do the simplest squared one, or even powered one. What does x squared look like?
Mm.
Isn't that just a parabola? Isn't that just a parabola that goes up?
Okay, yeah.
You see how they're both going up?
And
this is just a parabola going down.
Okay.
Right? It's just a parabola. That's all this is. You remember that? So really, all you really have to think about is just think about the simplest equations that you can think of that have that same property. The same degree and the same leading coefficient. That's all you have to think about.
Okay.
So when I see this, I immediately just think, oh, this is an odd positive, and I just think of x equals 1. So it's going down left and up right. Does that make sense? Okay. And now how do we graph it?
Plug in the x squared and then x minus 5, 2x plus 3, and no. Sorry, is it?
How about we just put the dots on the graph? So there's one dot. There's -5. There's another dot. There's -3 halves. -3 halves is between -1 and -2, right?
Mhm.
There's +3 halves. Okay. And we know it's going down at the left and up at the right. You follow?
Yes.
Does it go through? So we're going to start at the left and start drawing it. Does it go through -5 or does it bounce off of it?
Go through.
It goes through. Does it go through -3 halves or bounce off of it?
Goes through.
Good. Does it go through 0 or bounce off of it?
Goes through.
Look at it carefully.
Oh.
If it's multiplicity 2, what does it do?
Oh, sorry. It bounces off.
It bounces off. See how it went back? And then it's going to go through this. You understand?
Yeah.
So that's roughly what the graph looks like.
Okay.
All right?
All right. Yeah.
All right. I want you to try one now.
Yeah.
Do you want me to make one up or do you have another one you can give me? Yeah, I'll write it down if you want to just tell me what it is.
Okay. No. I can't find another one. Yeah.
I can make one up if you can't find one.
Okay. Yeah. That works.
Okay. Y equals x cubed plus 3x squared minus 4x.
Okay.
Tell me what that does.
So the number of zeros is 3.
Good.
And then the maximum number of turning points is 2.
Good.
And then we can take out x squared.
Not x squared.
X.
Good.
Just X.
And what's left over if I take out x?
X squared plus 3x minus 4.
Good. Can I do anything else with that?
No. Yes, you can. Sorry. The x plus 4 minus 1, and then x minus 1.
Perfect. Good job.
Oh.
So what are my zeros?
X equals 0.
There's one of them.
And then x equals -4.
There's another one.
And then x equals +1.
There's another one. Actually, let me change this a little bit because they're kind of close. So let's make it. There's -4, there's 0, and there's +1. Okay.
Okay.
And what's the end behavior look like?
So the leading degree is odd.
Okay.
And then the leading coefficient is positive.
Okay, so which way is it going?
So it's going left in behavior is.
Think of y equals what? What's the most simple positive odd function you can think of?
Y equals x.
Very good. Which is just a what?
It's just a line.
That's right. Going up from left to right.
Yeah.
So it's down and up. Make sense?
Yeah.
So does it go through? So where should I start? Should I start here? Should I start here? Should I start in the middle somewhere? Where should I start drawing this thing?
On the far left
Good.
arrow,
And does it go bounce off or go through at -4?
it bounces off
Why is it bounce off?
because it's positive,
Nope.
or because it's even. Sorry.
Nope. It doesn't
Oh.
matter if zero's even. It matters if the multiplicity is even. What's the
Okay.
multiplicity of each of these zeros?
X equals 0 is multiplicity 2.
Nope. What's the degree on this that you don't see? It's 1, right?
Oh, 1.
Degree on this, 1. What's the degree on this? 1. That's multiplicity.
Okay.
So each of these is multiplicity 1.
Okay.
Got it?
Yes.
That's when it doesn't matter if the 0 is even or odd. It doesn't matter that this is an odd number, -4. That doesn't matter. It matters that the multiplicity is even or odd.
Okay.
Got it?
Yeah. Okay.
So what do we do?
So the multiplicity is odd, so we go through it.
Okay.
And
And
then
how about the next one?
the next one we also go through.
And how about the last one? Whoops.
And then we go through the last one as well.
Yep. Good job. Want to try another one?
Sure.
You want to find one?
Yeah, I can try and find one. There's 1x to the third plus 5x squared plus 4x.
Mm-hmm.
And then the number of zero.
That's it?
Oh yeah, that's it.
Okay.
Or do you want
No, that's
to?
good. That's good. Do it.
Oh,
This
okay.
this one's just like the one we just did, right?
Yeah. So number of zeros is 3. And then the number of turns is 2.
Mm-hmm.
And then it factors out as x. You can take x out. Then it's x squared plus 5x plus 4.
Mm-hmm.
And then it's x plus 1, and then x plus 4.
Good. So what are my zeros?
X equals 0, x equals -1, and x equals -4.
And what are the multiplicity of each of them?
1. Multiplicity 1, and then x equals -4 is multiplicity 1.
Yeah, and all of these, by the way, when you add these together, it's going to add up to whatever your degree was. Just so you know.
Right.
Okay.
Okay. Yeah.
So how do I graph it? Which way is it going to go?
We'll start at the bottom, and then on the left corner.
Okay, and go where?
Goes through.
Perfect. Then what?
Then it'll go through -1.
Yep, just like the other one we had, right?
Yeah. I was trying to find one with 4. at the other one. Okay, this one could work. 2x to the fourth plus 8x to the third
Mhm.
minus 50x squared minus 200x.
Okay. So what would you do first to this one?
The number of zeros and the turning point.
Okay. Number of zeros.
Is 4.
Good.
And then number of turning
point.
is 3.
Good. Now what?
And then you can group it. So 2x to the fourth plus 8x to the third will go together.
Okay.
And
Do
then
you want to take something out of all of them first or no?
we can try that. Yeah.
What do they all have in common? Don't they all have a 2 and an x? So then you'd have x cubed plus 4x squared minus 25x minus 100.
Okay.
Got it?
Yeah.
And what else can you take out now? Now let's group them.
Okay.
Now let's group them together. So what would this be? What would come out of here?
The x squared plus 4.
An x squared would come out, and you would be left with what if you took an x squared out?
Oh, you'd be left with x plus 4.
Good. And what would come out of this one over here?
Negative 25.
Good. And what would you be left with?
X plus 4.
Good. Now, if this wasn't the same, you couldn't do what we just did. If that wasn't the same, then you wouldn't be able to factor it by grouping. Just so you know. Okay. But since it is, we can take that out, right?
Yeah.
So I'm going to have this equals, let's write the 2x in front. Let's take the x plus 4 out. And what's going to be left behind if I take the x plus 4 out?
X squared minus 25.
Good. And can I do anything with that?
The x plus 5 and x minus 5.
Perfect. Good job. You getting the hang of this?
Yeah.
Okay, what are my zeros now?
X equals 0.
Good. That's one. Another one.
X equals negative 4.
Good.
X equals negative 5. And x equals positive 5.
Good. And they all have multiplicity of what?
1.
Yeah. Do you understand that now?
Yeah.
Which tells you when you're graphing them, what happened? What does that tell you?
That they'll all go
one
through.
Of my zeros. Yep, they're all going to go through. There's one of my zeros at negative 4. There's a 0 at negative 5. And there's a 0 at positive 5. And which way is this going to be going? Remember, think of the most basic graph that's an positive leading coefficient and an even. What's the most basic one?
Y equals x.
X squared.
Squared, okay.
Because it has to be even. And what does y equal x squared look like?
It goes.
It's just a parabola, right?
It's just parabola, yeah.
Opening up, right?
Mm-hmm.
So these are both opening up. Make sense?
Okay, right. Yeah.
And now, like you said, it all goes through. All of them go through. So let's just draw them all through. Try that again. Goes through, comes up, goes through, comes up.
Okay.
No problem, right?
Yes.
All right. Do you have other stuff to work on, or is it all of? Is this what you're doing for all of it?
It's pretty much what I'm doing. The first page of it was just a whole bunch of factoring and then stating the asymptotes and holes.
Okay.
Yes.
So that sounds like that was rational functions that you were dealing with.
Mm-hmm. Yeah.
Okay. Are you good with those?
Um,
Do you want to practice some of those too?
yeah.
We got
Let's
some,
struggle.
you got some time. We got 20 minutes.
Okay. Okay. Um, I have one here. Here's the first one he gave us. It's x squared, f of x equals x squared minus 9. And then it's like a fraction. So then on the bottom is x squared plus 5x minus 24.
Okay. So let's factor it first.
Okay.
There's x plus 3 and x minus 3, right?
Mm-hmm.
And then on the bottom, it's going to be x and x. And 24, it's going to be 8 and 3. A positive 8 and a negative 3, because that multiplies the negative 24 and it adds to positive 5.
Okay.
Got it?
Yes.
And then this cancels. So there's your hole, your removable discontinuity, or your hole. I don't know how your book calls it. Your hole is going to be at 3 comma. Now plug 3 back in here. 3 plus 3 is 6. 3 plus 8 is 11. So 6 over 11. So there's your hole at 3 comma 6 over 11. Got it?
Oh, okay. Plug it back.
That's all you got to do. Your vertical asymptote, all you look at for your vertical asymptote, I'm going to color code this for you. So your equation really is x plus 3 over x plus 8 now. And x cannot equal 3. Right? So now we're just looking at that. And your vertical asymptote has to do with the denominator. Look at the denominator and decide it equal to 0. X plus 8 equals 0, which means x equals negative 8. There's your vertical asymptote.
Okay.
Got it? Your horizontal asymptote has to do with the degrees of the top and the bottom. The degree of the numerator and it is equal to the degree of the denominator. And so the horizontal asymptote is going to just be the ratio of leading coefficients. So it's just y equals 1 over 1, which is just 1. So y equals 1 is your horizontal asymptote. Okay.
Okay.
Got it. Your x-intercept rather. Your x-intercept, all you do for your x-intercept is take the numerator, set the numerator equal to 0. So x plus 3 equals 0, which means x equals negative 3. So negative 3 comma 0 is your x-intercept. Okay. And your y-intercept, to find your y-intercept, all you do is plug 0 in for x and solve for y. So it's just 0 plus 3 over 0 plus 8, which is just 3/8. So 0 comma 3/8 is your y-intercept. Okay. And then graph it. So let's take our graph. X equals negative 8. There's your x-intercept, or sorry, your vertical asymptote. Your horizontal asymptote is 1. So y equals 1. This one was x equals -8. And your removable discontinuity, your hole, was at 3,6/11. So 1, 2, 3. 6/11 is just underneath that line, right? So make a hole. Got it? Your
Yeah.
x-intercept is at -3. So your x-intercept is 1, 2, 3 is right there, which kind of makes sense, right?
Yeah.
Your y-intercept was at 3/8, which is right here, which kind of makes sense, right? Because the graph is going to do what?
It's gonna go through.
It's going to approach there,
Which,
and it's going to approach there,
okay.
right? And so
Right.
what does this side have to do? Is it going to be down here or is it going to be up here? Because it's got to do something. You can plug points in, but you don't really need to in this instance. Do you know why?
Because of the vertical asymptote?
Kind of. Yeah. There's a
Yeah.
couple reasons. I don't know if your teachers taught you this or if I've taught you. I can't remember if I taught you this. But if the multiplicity, see how the multiplicity of this, I'm going to write this over here. Multiplicity is 1. Do you see how the multiplicity is 1? If the multiplicity of a vertical asymptote is odd, then it's going to approach it in opposite directions. So since I knew it approached this down here, I know that it's got to approach the left side of it. It's got to approach it going up because it won't approach them together. If this was even, then it would approach them the same direction.
Okay.
But there's another reason I should know that it had to be up there. Do you know what the other reason is? What would be wrong about the graph if I did this? What would be wrong about the graph? Look at the graph and tell me what the problem would be. If I drew it down here, what's eventually has to happen? Right here, what has to happen? Do you see how I'm crossing the x-axis again?
Yeah.
But how many x-intercepts did I have?
You had 1.
I only had 1. I only had 1 x-intercept, -3. So if it was down here, I would have another x-intercept over here left of -8, but I don't have that. So it can't be underneath here.
Okay. Yeah. Oh,
So that's the other reason that I knew it had to be on the left going up.
okay.
Got it?
Yeah.
I'll try another one.
Sure. Yeah. Okay, so the other one is f of x equals x to the third minus 2x squared minus 35x, and then over x squared plus 3x minus 10.
All right, so let's factor it first. How does the top factor?
X, take out x.
And I can take out something else probably too, can't I? It would be x, and it'd be 7 and 5. You understand how I did that? Good. And how about the bottom one?
The x plus 5 and x minus 2.
Good. So x plus 5 and x minus 2. So what cancels out?
X plus 5.
Good. So that means your hole is at -5, comma. Remember, -5, right? Comma. Now I'm going to plug -5 in everywhere to all the remaining x's and see what I'm left with. We can do this in our head. What's negative 5 minus 7?
Minus 12.
What's negative 12? Oh, and then what happens to this? What's negative 12 times a negative 5?
Times a negative 5?
Because it's negative 12 times a negative 5.
60.
Good. So that's positive 60.
Mm-hmm.
And what's negative 5 minus 2?
Oh, negative 7.
Good. So negative 67. 60 over 7. That's the value. Negative 60 over 7. And don't worry about that. That's just a decimal, right? So you can even write it as a decimal if you want, or you can write it as a mixed number. 7 goes into 56, what, 8 times?
Mm-hmm.
Negative 8. 7 times 8 is 56, right?
Mm-hmm.
So there's 4 left over. So 8 and 7/4 basically. So that's my whole.
Oh,
Okay. What's my, let's see what color I did, and I'll try to be consistent. Green, then yellow. Okay. What's my vertical asymptote? Remember, you set your denominator equal to 0.
Mm-hmm. The x equals 2.
Perfect. So x equals 2 is my vertical asymptote. What's my horizontal asymptote?
Uh-huh.
Now this, we have none.
Okay.
Because the degree of the numerator is greater than the degree of the denominator. Whenever that happens, that means we have a SLACI. Have you learned about SLACIs yet?
No. Yeah.
Okay. So you probably don't have to worry about this, but you would have a slant asymptote. But if you haven't learned about it yet, then I'm not going to teach it to you. It involves long division. I'm actually surprised they gave you this problem because you haven't learned about this yet.
Yeah. You haven't said anything about that.
So let's not worry about that right now. Okay. But you do have a SLACI and you do long division.
Okay.
To find it. So you're going to learn that soon. In fact, I'll just show you. You'll see what I'm talking about when I punch this in. When I punch in x times x minus 7 over x minus 2. X times x minus 7 divided by x, was it x 2? And if I look at the graph on that, I'm going to zoom in a little bit better. You see how it's slanted. It's not a horizontal asymptote. You see that? Sorry about that. For some reason, my phone was ringing. So that's called a slant asymptote. It's not a horizontal asymptote. It's a slant asymptote.
Okay.
All right. So that's what you had there.
Okay.
So I really can't graph this because you don't know how to graph it, since you don't know how to do SLACIs, but we can graph everything else about it. Well, let's find our x-intercepts and our y-intercepts. So our x-intercept, remember, that's where the numerator equals 0. So there's 2. There's one at x equals 0, and there's one at x equals 7. So 0, 0, and 7, 0. Okay?
Okay, right.
And your y-intercept, we already know what our y-intercept is because we already wrote it. That's also our y-intercept, right?
Yes.
So when we try to graph this, you're going to run into a tiny little problem because all you have is a vertical asymptote, and you don't have a horizontal asymptote, so you don't really know what to do. But just trust me, you have a slant asymptote that we showed on that graphing calculator, and it's going to go something like this. Well, let's plot our points first. 0, 0, 7, 0, and what's my other point that I have? My whole -5, -8, and 4 7s. It's down here. So you have some sort of slant asymptote, and I don't know what it is off the top of my head, so I didn't solve for it, but it's going to be something like this.
Okay.
And your graph is going to do something like this then. And it'll do this as well.
Okay. Hmm.
So again, they probably didn't give that one to do to you, I would think, right?
Mm-mm. Yeah.
So anyway, that's probably about it. You feeling good about this?
Yeah. Yeah.
Good. You should. I think you got this.
Okay.
So
Yeah,
good
I'm a little
luck with
bit
it.
nervous. Yeah.
You don't have to be nervous. Just keep practicing. Go back to my website. There's lots of practice on my website. Okay.
Mhm.
204tutor.com. Go to the videos page and you can